What's up, everybody? Welcome back to 8th grade science. In this station, you are reviewing 8.5D. And what 8.5D talks about is counting the number of atoms of certain elements in a chemical formula. Okay? This whole big top part is actually a worked out, complicated example for you. I'm going to go through how they got their answers. Then we're going to define the difference between atom and element, which I've done a poor job of explaining this year. And then we're just going to practice over and over, all right? So to start, if we're just counting how many atoms are here, first thing I want you to do is I want you to box this in, Ba3. I know that this is one element because I have a capital and a lowercase, Ba3. And because there is a subscript of a 3, we know that there are 3 atoms of barium in the compound. That one's really straightforward. That front piece outside the parentheses, just look at your subscript. What is the subscript? How many atoms are there? We've done a lot of practicing with coefficients. Don't write this, but like where there's a 3 right there, we will not be using coefficients on the CA. Coefficients do not appear on the CA, okay? Now we get to the trickier part. We need to figure out how many phosphorus atoms there are and how many oxygen atoms there are. I know that these are different because they are both uppercase. It's not one element called PO. It's 2 elements, P and O. It's different than this where we had lowercase a. All right? So we need to figure out how many P's there are. This is where it gets a little trickier. I'm going to show us the math. I want you to work it out. P has that hidden 1 subscript. If there's nothing there, it's got a subscript of 1. And then you have to apply the subscript outside the parentheses. All you have to do is multiply these 2 numbers together. 1 times 2 for phosphorus. That multiplication should get us 2. There are 2 phosphorus atoms. We check our key. That's correct. Oxygen, same idea. Subscript of 4. Outside the parentheses, there's a subscript of 2. Multiplication gives you 8. All right? Perfect. Now I want to make a slight distinction. Come over here with me. We're going to write atoms. When you see the word atoms in a test question, it means add them up. Add them up. You want to add every single thing. So if it asks how many atoms there are of oxygen, you're going to use your subscripts. Add them up. You've got 8. If it asks how many total atoms there are in the molecule, look at this. We added 3, 2, and 8. That got us total atoms of 13. If it says atoms, add them up. If it asks for how many elements, it's asking how many different types. If we're looking at how many elements there are in this compound, there's 3. The first, and I'm going to switch colors. I want you to do this. You'll obviously have the same color. The first is barium, Ba. The second is phosphorus, P. And the third is oxygen, O. So to drive this home, I want you to do this arrow like this. We have 13 atoms, because we added all of the subscripts. We have 3 elements, all right? I want you to scoot down to the part called counting using models. I'm going to give you an example of this, and I'm actually going to give you 2 more examples, and then you're free to work on your packet. Counting using models. Which 2 compounds listed below have 2 or more atoms of the element modeled below? Circle them. So what's important to me, I know that 2 or more matters. And then I need to figure out what element we're talking about, because I'm not going to tell you. You need to read this model and figure that out. The way you read one of these models, the thing that determines atomic, right with me, identity. If you know it, fill it on in. It's the driver's license of the atom. It is the number of protons. If you find the number of protons, you check it against your periodic table's atomic number, you find your atom. Okay? Here I see that I have 12 protons. I want you to come up here. Right, 12p plus. And then what you need to do, you should check the top of your table where your periodic table is. I'm going to switch screens. I need to find the element that has an atomic number of 12. I start up top, 1, 2, 3, 4. I got to keep moving. Here I see 10. I found it. 12. Magnesium. I'm going to come transfer that back to my work packet, and you should do the same. Oops, wrong video. I want you to write Mg and circle it. That's what we're looking for. We need to circle all compounds that have 2 or more Mgs, okay? I'm going to come back to black. This first one has an Mg, but it's got only 1 Mg. That's not our answer. This one, I'm going to cross it out. This one, no Mgs. I found one. Mg2. That's got 2 magnesiums. Na2OH4, no magnesium. CH3COOH, no magnesium. NaOH2, no magnesium. Found another. Check my subscript. It's got 2 or more. Mg2Si. H2O, nothing. C6H12O6, no magnesium. Okay? That's how you work a problem like that. It's just a little tougher because you have to read the model. There are 1, 2 more examples. I want you to work on those when the video is done, okay? But I can work a few more examples. So I want you to flip your packet to the bottom of the second page where it says counting using parentheses. This is another way we have to be able to count. The number of elements, underline this. This is on the second page. Pause if you weren't there. The number of elements in a molecule is how many different atomic symbols there are. This is what we talked about earlier. If I talk about elements, how many different types? The number of atoms is found by counting all the subscripts. And I want you to write atom equals add, like the little abbreviation for them, add them up. All right, here's an example, and then you are going to have a lot of practice with this. AlSO4. I'm going to take my pen or pencil, box in Al. That is 1 element. Then I come here, I see SO4, but I know because I'm an experienced 8th grade scholar that this is 2 elements. They're both capital letters. So I have S and I have O. That gives me 3 elements, Al, S, and O. Now if I'm trying to do atoms, I'm going to add them up. I have 1 Al. I'm going to get rid of my boxes. I have 1 Al, that hidden subscript. On S, I have a hidden subscript of 1. And on oxygen, I have a subscript of 4. So in total, I have 6 atoms, 1 Al, 1 S, 4 O's. That is what you're going to do. You can flip your packet over and over and over again on page 3. You got 4 examples for you. Count up the elements, put them here. Then list just like I did. If you need a model, just look back to page 2. It's got an exact model. All right. This question is the trickiest. If you want to put a star by 2, 2 is the trickiest because it has parentheses with a subscript, okay? Keep moving down. We've got 2 more examples, then I'm going to set you free. Determining elements by model. This one, I'm not going to give you an example because I think we are capable of this, but I want to highlight a couple things. How many electrons are in this atom? Remember, electrons are in this cloud. You're going to count up how many total electrons there are. Put that in that blank. How many valence electrons? This means outer shell. Only count up how many electrons you see on the outside. Is this the atom reactive or stable? Remember, 8 valence electrons makes it stable. 1 to 7 makes it reactive. So it's got to have 8 in the valence to be stable. Got a full van. And then why? You should explain to me using the size of valence shell. Okay? There are 2 examples that look like that. Right here, right here. Oh, I'm sorry. On the very back of your packet, it looks like we got 1 more. Okay? Finally, counting using nonlinear formulas. This is the last example. Nonlinear formulas are chemical formulas where different atoms of the same element are listed in separate places. I want you to write messy room. We talked about how linear formulas are like a clean bedroom. Your socks are all in bundles. They all are gathered together. A dirty bedroom is like these nonlinear formulas. You've got stuff spread out everywhere, so your counting gets a little bit tougher. Let's read this example. Ethane is a molecule that's used in making plastics, like those pictured at the right. Ethane is also used as a refrigerant, a substance that makes things colder. Okay? We're going to take a look at two different formulas for ethane, count up how many there are of each atom of each element. Okay? We know how to do this. This is simple. You should be able to do that without my help. Tell me how many carbons are there, how many hydrogens are there. That we have to be doing right. This gets a little trickier. Come over to the linear formula. I want you to underline every time you see a C. I see a C once, I see a C twice. I look at both subscripts on the C. They're both hidden ones. That means I only have 2 atoms of the element carbon. Now I want you to do the same thing. I'm going to switch colors and I'm going to do boxes. I want you to box in the hydrogens every time you see one. I see one there, and I see one there. This is a little trickier because each box is 3. 3 plus 3 gives me 6 hydrogen atoms. Now we need to do our practice. There are how many elements? There's carbon and there's hydrogen. There are 2 elements, and there are blank atoms. 2 plus 6 gives me 8 atoms. When it says atoms, add them up. There are 2 elements, 8 atoms. Okay? Last thing you are going to try is you are going to do a bunch of examples doing the same thing. Just trace along. When you see a C, underline it. When you see an H, box it. And let's agree that when you see an O, you'll put a triangle around it. Okay? Give it your very best shot. This video is done. I worked through a bunch of examples, but I didn't do the whole packet. I want you to go back now, start at the front, and work through the packet using my examples to help you. Best of luck.